A lot of HVAC techs check gas pressures and temperatures on new or repaired heat units, and so long as those numbers look okay, they call it a day. But an appliance can still be burning too much or too little gas, even if those readings look fine. I'm going to show you an easy test a lot of techs don't do that requires nothing more than a phone and a piece of information that can be found on any local gas bill. And it can reveal how much gas the appliance is actually using, whether that matches its capacity and efficiency rating, and it can even reveal problems in the sizing of gas pipe or pressure regulator issues. Now, the process we're about to do, it's called clocking a gas meter. I'm going to show you how to do it on a furnace, but you can use this process on any gas appliance in the house. Now, if you're a tech doing this on a new furnace, you want to go ahead and set your gas pressure. You want to go ahead and check your heat rise, make sure that's in range. If you're more of the homeowner, handyman type, hopefully this has already been done for you. And if not, the test we're about to perform will probably reveal that. Our next step is to make sure none of the other gas appliances in the house are operating and that any pilot lights for these other appliances are not lit. The whole idea here is that the furnace or whatever appliance we're testing is the only piece of equipment in the house consuming gas during the test. Our next step is we're going to go ahead and we're going to start up the furnace, and we want to make sure that furnace is firing at its highest rate possible. So if you have a two-stage furnace, you want to make sure that's firing in its second stage. We then want to let the furnace run for about a minute or two to stabilize, and then we can head out to our gas meter. What we're looking for on the meter is a cubic foot dial, and you might see a couple of them. You can see on my meter here, we have a 2 cubic foot dial and a 1/2 cubic foot dial. Doesn't really matter which one you use. If you have a 1 cubic foot dial, that's the best. I'm going to use the 1/2 cubic foot dial, and at this point, it should already be spinning as your furnace is running. What we're going to do now is we're going to pull out our cell phone. Most of these phones have a stopwatch option on them. And as soon as that needle hits the top of the dial, we're going to start our timer. Now I'm going to time 3 passes on this dial, and you only really need one, but each pass is going to be timed a little bit differently than the next. So if you get 3 or 4 of them, you can average them out and get a more accurate reading. And once my dial makes that final third pass, I'm going to stop it and get our total. From here, we have to figure out cubic feet per hour, or CFH, and our numbers get plugged into a very basic formula. Now that dial in cubic feet, that's just the dial we used on our timing. So I used a 1/2 cubic foot dial. And so what we're doing is we're taking that in a decimal form. So if I used a 1 cubic foot dial, I would just put 1. If I had a 1/2 cubic foot like I used, I would put 0.5. If you use 2 cubic feet, it's going to be 2. If you use a 1/4 cubic foot dial, you would put 0.25. That 3600, that is just the number of seconds in an hour. Since we measured our time in seconds, we have to make sure we're working with seconds in our formula throughout. Revs is simply the number of revolutions that we actually timed. So I did 3 revolutions. You can do 4 or 5, whatever you want. Now, seconds is just the time on our stopwatch for 3 revolutions. So we had 1 minute, 24 seconds. We have to convert everything to seconds. And so 1 minute, 24 seconds is a total of 84 seconds. Now, when we do the math, we end up with 64.3 cubic feet per hour. Now, the next number we need is our heating value, or higher heating value. And this is just the number of BTUs that are actually in a cubic foot of gas. Now, you do have to keep in mind this does change from region to region and over the seasons, so it is a number you have to keep updating with the gas company. This information can often be found right on a gas bill. And if you're a technician, you don't have to ask for the customer's gas bill. You can do this right off on your own. What you're looking for is the conversion to therms number, as you see here, 1.066. Now, to get BTUs, we just multiply that by 1,000. So this would be 1,066 BTUs in a cubic foot of gas. Now, if you don't see that on your bill, probably just best to call the gas company, ask them how many BTUs are in a cubic foot of gas right now. So previously we got 64.3 cubic feet per hour. We multiplied that by our gas factor, or 1,066 BTUs, and that gives us a total input on our furnace at 68,543. Now, the final thing we're going to look at is the data plate on the furnace itself. These data plates will tell you what the heating input is in BTUs per hour. That's rated for that furnace. So on this particular furnace, it's 60,000 BTUs for natural gas because that's what we're measuring on. Yet we measured over 68,000 BTUs when we clocked it. So this furnace is actually overfiring. Even though I adjusted the gas pressure on it and the temperature rise is good, we're still overfiring a little bit. So at this point, I can go back to the gas valve. Maybe I could back off on it a little bit. You don't want to go too far with that, though. These gas valves, they do have to operate within a certain range, and you don't want to be outside of it. At that point, if you can't get there with a small gas valve adjustment, probably looking at a hardware issue. Maybe the orifices on the manifold are the wrong size. Maybe the gas line's the wrong size, or it might be an issue with the gas regulator.